So the very last M calculation is molality. And notice that instead of a big capital M, it has a little lowercase m. And here's the real kicker. For molarity, we would say that something was 2 molar, but this is 2 molal. So take a second, laugh at yourself saying molal a couple of times because it's still funny, just all the time. But it's very different because it's moles of solute divided by kilograms of solvent. Okay, so completely and totally different. Moles of solute are the same as molarity, but this kilograms of solvent is totally different. If you look at molarity, it was liters, so we were focusing on volume, okay? This one right here is useful because you don't have to have any volume whatsoever. You only have to have mass. So it's pretty useful sometimes when you don't have the ability to take a volume or something like that. But to be honest, molality is used the least of the three. In recent years, people have moved away from it, but I feel confident that you guys would see it in like a college class or come across it on maybe some websites that you were using to like study and stuff like that. So I think it's still worth teaching for now, okay? So the good news is that it's really easy to do. You just plug and chug it back into the formula like we've done with these other ones. Just make sure you have your formula down. Moles of solute, kilograms solvent. So if we mass 5.36 grams of KCl and dissolve this solid in 56 milliliters of water, what is the molality of the solution? Well, I need moles of solute and I need kilograms of solvent. So I've got to look here. I've got 5.36 grams of KCl and 56 milliliters of water. That means I have 56-ish grams of water, so I have a lot less KCl. KCl must be my solute, so I need to convert this grams of KCl to moles of KCl. So 5.36 grams of KCl. Use my molar mass again. We're going to have lots of that, but I think you guys finally have molar mass down. Can you believe there was a time when you didn't? Okay. We got 3 sig figs, so 0.0719 moles. And then I need kilograms of solvent, but I have 56 mils of water. So I'm somehow going to have to start out with 56 milliliters and end up with kilograms. Well, you had lots of practice in this last unit converting between volume and mass, especially with water. You use its density, and there's 1 gram per 1 milliliter, just for water, of course, though. You would not be asked to know the density of anything else without it being provided to you. And then after I had grams, I need to convert to kilograms. Kilograms are big. There's 1,000 tiny grams inside of them. And this ends up being 0.056 kilograms of water. So, got all this good stuff going on. I've got my moles of solute. I've got my kilograms of solvent. So I can just find my molality now. So it's 0.0719 moles divided by 0.056 kilograms. And 2 sig figs is all we're allowed, so it's 1.3 little m, 1.3 molal solution. Okay? All right, very last one. I want you to try it before I go over it, so take a second, pause the video. Excuse my capitalization here. Okay. Oh goodness, there's a train. Hold on. Okay, sorry about that. We get periodic trains here. So how much acetic acid in grams is needed to make a 3-molo solution containing 25 grams of potassium cyanide? So in order to do this, I need my moles of solute, kilograms of solvent. My solute is going to be my potassium cyanide, so I need to convert this 25 grams to moles. Use my molar mass. From my periodic table, it's 65.12 grams, or 0.384 moles. Okay, after that, I've got the molality, but I need to find my kilograms of solvent. That's what I'm looking for, and then that way I can find my mass of acetic acid. So I'm going to plug it in a little bit differently here. I have 3.0 mole equals 0.384 moles divided by my kilograms of acetic acid. And I'm going to abbreviate that for time purposes. Now I need to go through and I need to solve for this kilograms of acetic acid. So I'm going to multiply both sides by my kilograms of acetic acid, just like with my gas laws back in the day. It really wasn't that long ago, though. And it ends up, then I divide by 3, and I get 0.384 moles divided by 3.0 molo. Okay. Our units end up canceling because this is moles per kilogram, right? So moles cancel with moles, and we end up getting 0.13 kilograms, which I then need to convert to grams because it specifically says in grams up here, okay? So kilograms times 1 kilogram is 1,000 grams, and I get 130 grams of acetic acid as my answer. Sweet. So that is the end. That is our third calculation here. So we really had 5 different sections of these notes. We had the basic stuff, what's a solution, what's a solvent, what's a solute, and that's important because every one of these calculations asks for different things. You have to be able to identify what the solute is so that you can find the mass of solute. Mass percent's pretty straightforward. Molarity also is, and it's really, 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 really important. And you can use molarity in turtle problems, dimensional analysis to do some really fun things. And then finally, molality. Okay, so this is it for today. This was a lot of notes, but this is the only notes that we're going to have for a couple of days. Okay, so we're just going to be practicing now with these 3 types of calculations. So if you're feeling overwhelmed, please don't be, because now we're just going to practice. All right, see you guys soon.